lot of technical stuff. It's not like, I guess you solid. And just check out and get someone else to post it there.
Okay, yeah.
Somebody else can do it and we can retweet it. Hello, everybody. Everybody sitting comfortably. Brilliant. There we go. Thank you, everybody, for coming out into the darkest night of Berlin to have a world's first ever official Matrix and Friends meetup. So, yeah, basically, thank you enormously to Philip and BlueYard for hosting us in their amazing office and amazing space tonight, and for the free beer and pizza. So, thank you, Philip. And I guess we should probably introduce ourselves.
Let's go.
Yeah.
So my name is Amandine, and I'm the founder of Matrix.org. And I guess we should still say what Matrix.org is.
Does anybody not know what Matrix is? Are you horribly lost here and wondering what? Oh, God, this is like the first ever. Oh, we have one person who admits not knowing what Matrix is. Okay. We'll have we'll explain what it is. And yeah, I'm Matthew, and I'm the tech founder on Matrix. And somebody actually asked me just now, already forgotten who it was, sorry, as to who are we and why are we doing this. And it probably makes sense to give a super quick introduction. Basically, we used to work on a proprietary, closed source, centralized project for a big corporate telco supplier, which was doing messaging apps for telcos, and I did the tech, and then did the business, and this was all great and wonderful. And so we basically had a midlife crisis and said, why are we doing this? Why does the world need yet another centralized messaging app which is branded by a telco of all things? And the answer is they don't, honestly. And so we said, what are we going to do? Are we going to do something totally different, or shall we try to make the best out of the mess that we've got ourselves into?
So, well, the solution is start by the highest, the furthest goal and try to reach it. So we just thought that we could still try to build a nice proposition of let's disrupt communications, and propose to our overlord at the time to actually fund a completely open initiative which would break all the walls between the communication silos and allow people to actually build communication systems which can talk to one another, and users who have the choice and who can host their data and have the choice of encrypt their communication and get back the freedom and the control of their chat. And these guys actually said yes, because if someone was able to actually disrupt the public phone network, well, it would be better for them who are living out of the public phone network to be them rather than Facebook or Google.
Yeah. So basically, they were a bit crazy and said, hey, build Matrix and have fun with that. So we took the team who had been in various startups beforehand, and we basically took everything that we'd learned doing these centralized things, created Matrix as basically a second system done right, like all best second system projects. Here we are 3 years later, having still not quite finished it. Yeah, basically that's where Matrix came from, and that's why we're here talking to you about it tonight. I guess the punchline of the story is that the big corporate telco overlord decided that they'd had enough of funding it a couple of months ago, and said that, hey, go free and work out how to support yourselves going forwards. So you're probably all aware of the amusing temporary hiatus that we've had whilst going, and ironically, at a kind of critical points from growing Matrix, just as the network is growing completely exponentially, suddenly discovering that we don't have a salary. But hopefully this is going to be resolved in the relatively near future. And meanwhile, thank you to everybody here who supports us on Patreon and Liberapay and Ethereum or Bitcoin or little gold chocolate coins or whatever things you choose to support us with.
I think contributions of fixing.
Yes, GitHub contributions and bug fixing, and contributions, heaven forbid, of code, which are even more valuable than chocolate golden coins. But basically, that's where we're at today. And what we wanted to do was basically have a very free-form chat about what we've been doing recently on Matrix, the present, a bit of sci-fi to look into the future. But honestly, it's such a intimate setting that if people have their own interests and questions, we're basically going to throw it open for people to ask and steer it whatever direction they want to go. But before we do that, we'll just do the boring, this is what Matrix is. So as we said, we're creating an open, decentralized, encrypted comms network, which is basically like the web, but for real-time communication. Hopefully this isn't news really to anybody. And what does it look like? A whole bunch of silos. Could be systems like Slack or Gitter, or it could be networks like, or it could be applications like GitHub, or basically anything. Matrix goes and sits as this decentralized mesh between it all.
And make sure you connect them together.
Yes, matrices. That's why it's called Matrix. If people haven't realized, it's called Matrix because it does matrix together other silos which otherwise would talk to one another. And of course, the overall stack of the thing is that you have the specification, the client-server API, which defines how everything talks to one another. You've got on the client side, JavaScript, iOS and Android, open source implementations, as well as on the server side, Python and Golang and Dendrite, and bridges through to all sorts of other protocols. You're getting lots of panicky calls from people.
I was trying to see whether the team was yelling because, oh, there is no audio or something.
No, I was just getting phone calls.
To be okay.
Actually, it was a phone call from one of our ex-corporate overlords, and so a little bit of paranoia in me is thinking, oh, we're live streaming this. And here I am talking about them as corporate overlords, and yet they're also phoning me at the same time.
say hello to them.
Yeah, hello. When we say corporate overlord, it's actually a geek thing. We don't really mean that you're corporate overlords. It's a term of endearment and respect and appreciation for all of the support and funding that you gave us over the last 3 years. Basically, yeah, that's Matrix. Let's talk about recent stuff that we've been doing. And the idea is, should we demo as much of it as quickly as possible?
So the idea is, we have stuff to show you, stuff to tell you about. We're going to do lots of demos, and then it's...
Yeah, but should we try to do this in like 10 minutes to get through this whole list? It's going to be great. So, yeah, widgets. Who doesn't know what a widget in Matrix is? Oh, we have a couple of people. Okay, so widgets are really depressing from a technological perspective because they're really, really simple, but they're also kind of useful. So if you go into Orion, and here's Matrix HQ, people complaining about the darkness of the feed. Sorry, everybody, we're doing our best. It's looking good at the moment. Let's go to a room like Andy and I are testing in the Andy cookie room right now. These guys here are widgets. And the deal here is that you can take any old random room in Matrix with all of its conversations, and you can start taking basically iframes of any kind of arbitrary content and chucking it into here. So here we've got an embedded YouTube app, here we've got an embedded Etherpad. At the moment, it's very sort of initial implementation. You can only do 2 at a time. But what we're about to land in some point in the near future is the ability to do a Grafana style layout where you can have a grid of apps and you can take this one, extend it out to the side, take that one, extend it out, pin one up at the top, pin one down there, and basically create every room into a dashboard of different functionality. Oh, so Etherpad's a fun example because you've got the real-time text. So rather than going and doing the Google Wave thing of building that into the core protocol at the moment, synchronized real-time text for Etherpad. Likewise, if you want to hear the video, then you go and watch the video or whatever. If we went and got rid of one of these, like so, then we've got this button here, which takes you into an app store style thing, which lists what we already have in the room. You can go and add new ones, things like Jitsi. Oh, we can do a segue into the next demo. So you can do Jitsi, you can do YouTube, custom widgets is any random bit of web page. So yeah, technologically it's dead simple, but very few chat systems. Like, where is this in Slack? Why can't I not in Slack just say, I've got my dashboard, I want to put it in my room? I mean, it doesn't make any sense to us, but that's why we've gone and done it. So yeah, let's try doing Jitsi. So Jitsi, everybody know what Jitsi is? Open source video conferencing. Go and add the Jitsi thing in here. I'm going to join conference. Go and kill the Etherpad so that we've got more space to play with. And so yeah, here we have just me echoing back at myself over there. And so you're joining on iOS. Cool. So this is brand new. This is like a week old, I think. Going and integrating the Jitsi SDK on iOS and Android so that we can have relatively good, other than the fact that it killed the video because we're doing a live demo. Are you on the Wi-Fi? Yeah. Last time we did this, it was bouncing off England. Yeah. You basically get the idea of multiple conferences in there. I'm going to see if I can join it on my iPhone too. And you can see that it's what's called a stream forwarding unit. So it's not a multi-point conferencing server where you kind of go and mix everything together. Instead, yeah. So on iOS, you've got this big red bar at the bottom that says ongoing video conference. Go and click the button and hopefully, oh, I'm in here now. Oh, somebody connected. Perfect. We're going to get horrible hangarounds due to I'm probably going to crash the network, but you get an idea that basically it's Hangout style conferencing done as a widget. Yeah. So that's something we've been up to. Now, the big thing that we said we're going to announce and actually show in Anchor is groups. Now, groups is a brand new thing. This is communities in Matrix, the ability to, in fact, you want to talk about it.
So, yes. What Matrix is today is that a big list of room, a big list of people, and when you want to navigate, it's a bit of a mess. So we're completely missing this idea that if I'm doing an open source project, for example, I want to have a specific list of rooms dedicated to my project, and if someone wants to come and participate, they want to find me. They want to find the people working on the project, the appropriate rooms, and talk to the appropriate people. So what groups are doing is actually gathering all this community under a bigger umbrella, which are communities, and where you can actually define a homepage which describes what the community is about, which lists the people, the groups, and is a nice area to group people. But the good thing, you're going to tell me, well, that's what Slack does. But the good thing is that you don't need to create an account for each of your community. It's yourself on the Matrix ecosystem, and you have all your communities grouped together, and you can navigate between your school or your open source project or your work project, and everything is in one place, and it's just you navigating between it. You don't have to change accounts.
I mean, Slack, again, could have done a really good job of this, but basically they don't seem to care about open communities at all. So like the cryptocurrency communities or open source projects, you know, these huge sets of people with like 10, 100,000 people or whatever, and they say Slack is for internal communication for businesses, and they just don't seem to broaden things beyond that. So honestly, we went the other extreme. We were much more like an IRC network where you type /list and you get 20,000 rooms and think, oh, wow, this is completely overwhelming and unusable. And that's basically where we're at today, or historically at Matrix. So nowadays on Riot Web, on developers, on the develop branch, we've got this little button here called Communities, which, oh, hello, I haven't looked at since the CSS landed about half an hour ago, which gives you an idea of just how rapidly this is landing. And right now, I'm a member of precisely one community, which is plus matrix, go on matrix.org. So these groups, these communities, we use a plus sigil on the identity underneath. And if I jump into this one like this, and hopefully you get a bit of HTML that says, welcome to the very first ever community. And strangely enough, it's the official matrix rooms. And then we have a list of the rooms which are in the community, obviously HQ, Riot, blah, 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 blah. Basically the official rooms which we admin on the server. So we now have this nice subset of rooms, and people can go and link to this, and it will land them in it and say, well, oh, I know where I am, as opposed to I'm totally lost in the sea of random channels which you get if you hit the actual room directory button.
As you can see, the matrix core team has reduced quite a lot.
Yeah, we should probably invite some more people into that. So a good example of the UX of going and adding somebody in. Well, we can't. This is working behind the scenes, honestly. So if I could invite somebody who's not in there, I'm going to invite Dave. There's Dave. He's one of the guys who's been working on the front end of this, and invite to community. There we go. The community invitations have been sent, and I'm sure that they will have been received as well. You get an idea. Oh, something that we should have shown and completely have forgotten to is the whole idea of flare. I wonder if this is going to work at all. So if we go and jump into a room like Matrix HQ, and I say something, hello world. Yeah, okay, well in theory, oh, no, it's working. It's just, I'm on the dark theme. Yeah. That's really embarrassing. And so let me change to the light theme so we can see what's going on. Where are the themes on this? This is the worst screen in all of Riot. There it is.
And every time you do a meetup, you have to demo.
Yes, I know. And now we've gone and broken the color balance, and everybody on the stream is going to be upset again. Okay, you can see just about there is this tiny little M logo next to my name. Now this is actually a relatively big deal because it's showing that I'm an official member of the Matrix team, and it basically allows you to have badges which you can put on your name of whatever groups you happen to be a member of, assuming that the room itself is within that community, so that people can identify themselves as being core team, or being a supporter, or being a hello James, or being a member of whatever little group you like. So it may sound relatively minor, but we think it's going to be a massive, massive change. It's been ages coming, honestly, because I guess we've been a bit distracted over the last couple of months, but also there's been a big dilemma on how you do groups. And then the choice on the technical level is, do you go and just use rooms and say you have a room with a bunch of people in it, and we declare that that room is a group effectively, and then rooms within that group are just a subroom within that room, except it doesn't map that nicely through to things like LDAP groups or Active Directory or whatever existing single sign-on system you might have, or identity system, or not. And at the moment, the implementation has gone completely to the other extreme. There's a whole new set of APIs which look and smell a little bit like groups of people like you find in rooms, except it has the potential to be backed by a variable-defined single point of control, which is sort of useful from an ACL perspective, because unless you go and wrap everything up in a blockchain-y style thing, or you have some other kind of consensus mechanism to have variable-defined ACLs which are propagated over the system, yeah, we've basically gone for the federated model, or even a centralized model per server for a given group. So for instance, this one, plus Matrix on matrix.org, is owned by the Matrix home server, so you have a very well-defined point of control as to who's in that group. We don't think this is a complete disaster, given that the actual conversations are decentralized, but I think it's probably fair to say this is a first cut of the group APIs. Charles, any questions about groups, what we're talking about? Is it as exciting to anybody else as it is to us? Yes. I'm going to assume that's the second answer.
I just wanted to know if it would be possible in a custom Riot instance to define my home group and have the introductory screen rendered.
Yep, absolutely. So this will very much replace the home page. At the moment, we do still have the old school home page. Now, we'll probably keep it because you can go completely freestyle on it. You can put any HTML you like. Whereas on the groups, it's a bit more limited because we don't want people doing XSS attacks and everything else on it. But yeah, there is nothing remotely proprietary or locked down on these. This is a core part of the Matrix protocol, which will get specced as soon as we have somebody able to, in a position to work on the spec. And yeah, it's there for everybody. Other questions?
How does administration of the group look like? Can you
of course. Sorry, that's a really obvious bit of groups that I probably should have demoed. So if I go back into the groupy thing, yeah, and you go to the right group, then we go and click on the top. Then at the moment, you literally get to put whatever HTML you like in there, and it probably should be marked down, but as the first copy of it is HTML. You can say whether you want to have a badge on your name, should it be published on your profile, and then if you wanted to add a room into this, and I don't know, wanted to add, what happens if I search for GitHub, random things come up. I could add one of these guys in, and it goes and gets added in there. And you also have a list of the rooms here, which has the Lex icons to remove them, as well as managing the list of people. And Dave was not only invited, but he joined, so let the demo work. Yeah, so that's basically the admin interface. It's very much the first cut, but I think it should be useful in its current state, and it's landed on proper develop on both Synapse and Riot as of the last 25 minutes also. Other questions? Cool. So what's next?
Docker.
There's not really much to say about Docker. Shall I quickly say the Docker thing?
Yeah. But you know that my knowledge of backend systems is relatively limited.
Okay. So on Docker, we've got an official Docker image coming out last, something that people have been asking for ages. It's on a PR. It's quite similar to the Sylvia one that people might be using. It looks pretty cool. After you.
So yeah, this landed quite a few weeks ago. It must be this summer at some point. And basically, we actually merged some of the changes which has been done last year as part of the Google Summer of Code project, and just finished it to put it here. And now you can easily and nicely add cool smileys and actually format the text either by using the markdown bar here, or or just by using simple shortcuts like you would do anywhere else.
Yeah, so I mean, this was ages in coming. It was a nightmare to merge, and we're using the Facebook draft.js rich text editor library there, which has not been the best thing in the world to work with. It does some really weird things. It basically completely replaces chunks of the normal browser ecosystem, overrides Control-Z and has its own undo implementation. That sort of that's always going to work. And the number of reports we have about people who complain that they can no longer replace this with their Vi or their Emacs embedded text editor is enormous, which gives you an idea of the Matrix community today. And we're actually about to add a thing into it, which I saw somebody working on, I forget entirely who, I think it was someone in the community actually, who's going to allow you to turn it off again. So if you do want to put your embedded Vim in there, you can.
We also added, improved the mentions in the UI and made them into little pills, some that people usually really like.
Right, so,
makes it much easier to spot when people are actually mentioned. And not only
we're sort of preaching to the choir at this point, because everybody's going to be playing with the mentions, right? Well, you might not know about @room. @room is the most annoying feature that we've added ever. So we're already regressing it, mainly because we screwed up the defaults, such that the idea of @room is that the only people who can use an @room to bing everybody in a room should be the admin. Seems reasonable. Unfortunately, because it's a new feature, it was implemented such that the existing legacy clients don't know about that check, and so if they're doing a client-side bing, they will still go and bing because they don't know to check whether you're an admin or not. So don't use this, please, until everybody is upgraded. Until everybody's upgraded. And it's also a really hard thing to work with and debug, because the first thing people say is, oh, have you been working on @room today? And immediately everybody gets, what's going to be big me? @room doesn't seem to be working. Anyway, so basically it's a terrible idea, although one that a lot of people like from Slack, and as more and more people are migrating over, we thought we would add it just to keep everybody happy.
Yeah, we've been pushing back on it forever, and people were pushing too hard, so we gave up and actually did it.
I bet nobody knows about this one. Does anybody know about pinned messages?
Yeah, used in my room.
Okay, awesome. I'm glad somebody's using it, because we haven't spoken about it.
That's the same thing, something we've been willing to do since the beginning, because it's very well to communicate the whole day during the chat, and then you just forget what you're meant to be doing. So the ability to actually just pin the message at the top of the room, and then you can refer to it quickly. This has been even in the contribution, right, from Travis?
From Travis, yeah.
Yeah. So thank you, Travis, because this is great.
So that's it. You can go and pin a message like that, and we need to get some UX feedback that it actually got pinned. But then, come on, you can do it.
Done at some point.
I think it updates in real time when it actually appears. Yay, there we go. So yeah, obviously need a bit more UX feedback, and I think the server just for a change is completely overloaded. But again, it's a really nice, useful little thing, and thank you, Travis, for implementing it. That's hidden behind the labs flag if people have been wondering why they don't have a little pin and pin messages. What else? Oh, these guys. Like, has anybody seen the push kit or cool kit stuff on iOS? Does anybody care about iOS? Yes, because on this. Sorry, I'm obviously an Apple fanboy, unfortunately. This is actually kind of fun for Android too, because the push kit stuff is finally doing client-side notifications entirely. So we've had a long-lived privacy issue that for some platforms we were pushing the body of messages over to the push server, which is obviously not great if it's owned by Apple or Google. So this is the final step of shifting everything. So the only bit that we send to Apple or Google is the wake-up thing, and then the app sits in the background and sends stuff. But the really fun thing is that the app sitting in the background to display the push can speak end-to-end. So if you want to have a complete contradiction in terms and have your end-to-end encrypted pushes that be displayed in plain text on your lock screen of your phone, then now you can. And it's actually kind of useful because the more encrypted rooms you're in, the more messages you need. So I'm not going to bother demoing it because nobody gets about iOS. We can check the cool kit.
The cool kit is quite good to demo.
It's like all best owners. Oh, let me share my screen quickly.
Yeah,
so
that's behind there.
I'll give you a chance to something. It's going to work. No, it's not going to work. Hold a sec. Okay, so here is my phone. Welcome to my world. Only 13 missed right notifications. So you calling me?
Yeah.
It's not working.
Oh, I was waiting for it.
Oh, cool. So hopefully, I'm just minding my business, waiting for the server to forward an mcall.invite, which is a very interesting event, very similar to a SIP invite, which goes and tries to establish the inbound call. My laptop, meanwhile, is, oh, I guess that's the AirPlay, and hey presto. So this is actually coming in as a native call UI on the phone. So it's also ringing my Android and it's ringing all my other devices too. But this is kind of fun because Apple added this as the ability basically for VoIP apps to properly hook into the guts of the OS and behave as a native call replacer, which is fantastic for our secret mission to go replace the PSTN. So if I answer it, then it's going to go into a one-to-one WebRTC call.
No, it doesn't because I hang up.
You hung up?
Yeah, because it said that you did not answer.
Okay. Oh, yeah, I guess I probably should have.
It timed out.
Okay, so that gives you an idea. Oh, it's a cookie from the cookie room. What else have we got here then? Matrix and WebVR. Let's talk a bit about that later because we're running way too late now. Synapse performance and web performance. We've done a lot of work on Synapse trying to make it suck less. And basically, every time we get another 50% of headroom, our traffic increases by 50%. And right now we're actually right up at the cusp of headroom on the, we're at the ceiling of matrix.org, as you can see in the performance, but hopefully we'll find a new way to speed it up. Right, web performance. If you like performance stuff, go and search for Riot web performance on GitHub and you'll find an embarrassing bug where it turned out that the very first version of Riot, Proto Vector 0.1, was one of the fastest chat applications I've ever used. So changing room happened in about 18 milliseconds, like 1/8 milliseconds. By this point, unfortunately, Riot Web is taking about, I don't know, a change room like that. No, it's not that bad. It's still, though, I guess you can't see, but it's about 100 mils, 150 mils, which by my standards is pretty slow. So we've basically been doing a lot of work trying to improve the performance of that. Let me get back in. Too many rooms. Right. And then Dendrite. So we're still building Dendrite, basically in Golang.
So for those who don't know, possibly not many people, but Dendrite is the new generation server, the one which is actually scalable, and it's going to replace Synapse at some point when we finish building it.
It's looking good, and we've been starting to get a bunch of contributions from the community, which are really cool. Yeah, basically, we're trying to crack on with it, but keep getting distracted by Synapse or other issues, and we don't have anything to demo because it looks and feels just like Synapse effectively, but we're continuing to progress with it. Right. I guess a quick thing that might be useful is to look at where things are at in terms of usage, These graphs are a couple of weeks, about a month old actually, but give you an idea of the number of users on the matrix.org server itself. I think we're almost up at 2 million registered users on that. But in terms of activity, looking again just at the matrix.org server, we're actually well over 1 million messages a day. You can see that the encrypted stuff is taking off much more slowly because, as we all know, there are some issues still with key sharing on encryption, unfortunately. And then finally, the number of servers out there, I think we're actually up at about 4,000 now, since that was done at the end of August. And those are literally the number of folks that we're federating with on matrix.org. So as you can see, the graphs are all going up in a slightly scary manner. That means we spend too much time trying to make the Python go faster. Oh God, this is, we've been doing this for half an hour. How should we play this?
We have 15 minutes.
We can look at do the whole what's next stuff, and then
just quickly, yeah. That's quick.
It doesn't matter because it's not boring.
Okay. Thank you. Yeah, end-to-end. So end-to-end has suffered from our funding stuff, honestly, in the but the combination of the scaling and the funding stuff means that the time that we should have spent finishing end-to-end has been spent desperately building Dendrite or Synapse. And it's a bit embarrassing because there are still edge cases where keys aren't shared for devices in the room. We did get some of the infrastructure in place, which is when you add a new device on, then if you're on web, but only if you're on web, it will go and synchronize the keys from other web clients if you have them. But it's a bit of an edge case, but at least it's got the kind of infrastructure for sharing keys in place. But we need to do a lot more work.
Yeah, so basically the next step are really to implement the key sharing on the mobile side of things, and then get a crack on the UX and try to find the best way to make this nice thing actually transparent for the people who are more used to things like WhatsApp, and while still being tunable for people who actually really care and want to have visibility on everything and be able to blah, 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 blah. So yeah, that's a nice compromise we have to find.
I mean, a good example of the UX stuff is that you're probably familiar on Riot Web that when you put a message into an end-to-end room with a new device in it, you get this horrible dialog box that comes up saying, "Warning, there's a new device in the room, panic, panic, panic," which is horrible. Obviously, it should just have a little thing in the status bar to say, "Warning, we're holding your message until you can validate the new device," or something like that. We just haven't got there yet. But it's still very much on the list as quickly as we can get to it. It is literally top of the list. We've already talked Dendrite to death. Widgets. Now, widgets is going to be interesting because it's one of the things, especially on the payments, that can help us get out of the funding fund that we're in at the moment. Stickers are another aspect of that. We don't have stickers today, and an obvious thing that, for better or worse, lots of messaging apps use to go and make some cash is to go and say, "Hey, here are a bunch of free stickers. If you want to pay however much to get a custom sticker pack, then you can." We're not going to do any evil DRM on this. Instead, it's just going to be a gentleman's agreement or a trust. We're basically trusting the users so that if they went and bought a fancy sticker pack, they're not immediately going to pirate it, and hopefully that will be great. So this would in practice be built into the autocomplete thing, I think, in Riot. Yeah. So as well as doing emoji, etc., you can also use stickers you bought, and you can also buy stickers via the widget, the App Store thing.
Next is the video broadcasts, so push further the what we have with YouTube now and GT, and have actually the ability to broadcast, and so that we're actually able to use our own technology to do our broadcasting our own stuff. So
this is really the Twitch kind of use cases, really, for natively built into Matrix as a widget. I guess not really using Matrix other than to coordinate the existence of the widget, but if it was tied in nicely and it used the ACL model and it used the users from the Matrix room, it could be pretty nice as a decentralized Twitch alternative. And then likewise on payments, it's, I guess, a alternative to the Patreon style model, where if we had the ability to add a widget to a room that says, "Hey, in order to access our premium supporters room, you need to pay us $5 a month," or whatever, then that could be another rather useful thing. Now, obviously, all of these would be available to anybody to run. So if you're a user and you want to set up shop and get people to pay to access a room or whatever it might happen to be, you go for it. So this will just be something out there. If people want to use it, that's great. If they don't, so be it. But it's just almost a warning and a heads up that we've got some of those sort of widgets on the horizon.
On the Riot UX side, aside from trying to sanitize it a bit, we're going to add reaction to messages, which is missing quite a lot. The ability to edit them in a better way than what we can do today. And potentially getting into threading. We don't know. The question on threading is more when, because we're going to do it because we really want to do good threading in Riot. But yeah, let's see when it's going to come up.
I mean, the ideal mission on threading is to allow you to bridge into message board style systems. So have a bridge to Reddit, have a bridge to I know Usenet, or a bridge to Hacker News or whatever kind of system, but also as a way to kind of manage conversations in a big IRC channel style semantic when you've got 8 overlapping conversations and the number of people, even on Slack, who have no idea how to use this thing because there's too much information. The idea that you can literally physically take the messages and split them apart. If somebody goes off topic, you physically take the message on the screen, you move them into their own kind of swim lane so they can go and talk to themselves. And yes, then you turn off the notifications for that thread that you've defined. Basically, the ability to retrospectively thread conversations, I think would be amazing if and when we finally get around to doing it, but it's not quite there yet. We've got some really nice UX mock-ups for it, which we were discussing in Riot Dev the other day, if anybody hangs out in Riot Dev, but there's still a long way to go.
Sorry, with editing, you mean that we can edit messages we've already sent?
Yeah. Yeah, so obviously this would be with history because everything is immutable in Matrix, and it's effectively isomorphic to threading in that you're creating a chain of messages which are flying off the side, except they're updating the single one rather than being a full good conversation. I guess the final thing to talk about is the Librem 5. Anybody not know what Purism Librem 5 is? Okay, a couple of people. So Purism 5, Librem 5 is a phone which is made by a company called Purism in the US, which aims to be 100% open source software. It's not an open hardware platform, but it is a completely FOSS stack in the software all the way up from the ground. So there isn't any proprietary microcode in the thing at all. Instead, the mission is to really have the Linux phone dream where people can control their own software, they can control their communications, because critically it speaks Matrix as its native communications platform, which is kind of fun in terms of the mission of Matrix replacing the phone network, if the phone natively speaks Matrix. And it's a crowdfunding project. I think they have 4 days left or 5 days left. They've hit their target. It's up to 120%, I think, at the moment. So it's going to happen. And it's good news for us because it means that we'll get some of that money to build some native Matrix clients written in Qt to basically give the best possible native phone interface there. And we're looking forward to working with the KDE community as well as the GNOME community to basically get Matrix into it. And the whole thing, honestly, is a little bit naughty on our side because it means that we also get to build native desktop clients at last for Matrix, which we've been wanting to do forever. And the community has been doing a great job with lots of native Matrix clients, but this will be a chance to go and really make sure that they have parity with Riot and other clients in terms of feature set. So we're looking forward to that. It's going to be at least, I think, 14 months, I think, until the phone exists. Which gives us enough time to hopefully write the software, so when it ships, it will have Matrix on it. And so if you want one of these, go and crowdfund it.
My name is Ike, I'm from KDE. We provide the user interface for the phone, and I'm working on a Matrix client on Qt as well. So if you have any questions about that, find me later.
Cool. Well, we should definitely talk about Matrix clients. Awesome. So at this point, choose your own adventure. We've got
4 minutes.
4 minutes in which to choose one of the benches, A through F. We've already done A, so we kind of cheated on that one. We could have some really boring lamenting about why end-to-end still isn't finished. We've sort of done that. We could mess around in VR for a bit. Okay, we've got a vote for VR. Yeah, go and like share, use the club commenter. we could do a deep dive into the Librem 5, but there's probably not much more to say than I already did. But okay, yeah. Okay, so we've got like 2 people watching Librem 5, 1 person on VR. We've got the whole problem of spam and reputation, the thing that will either make Matrix amazing because we solve reputation, or it will make it the next SMTP and be a complete disaster. So that's always a good conversation to have. Anybody wants to talk reputation? And then finally, yeah, the whole decentralized identity. That was not the one I was expecting or prepared to talk about. Perhaps I should put this to Max and keep to talk about later. Shall I wing something on decentralized identity?
Sure.
Okay, so actually we were going to have a talk from a guy, another guy called Max Dorr, who's based in Belgium, I think, who's been working on identity on Matrix, and is basically the only person who's really been flying the flag on that from the community. Because right now, identity is a mess in Matrix. It's, as you probably know, it's a centralized service which maps email addresses and phone numbers to Matrix IDs. And the only reason it's like that is because we haven't had any time on the core team to fix it. Now, I guess there are 2 directions you can take it in. Either you go down a federated approach or a more fully decentralized approach. Max Dorr's implementation is called MXISD, so Matrix Identity Service Daemon. And this is a federated approach, and it looks and feels a little bit like DNS, but at the application level. And so the good news is that people can run their own identity service for their own domains, but the bad news is that you need to only do it for identifiers which are already linked to DNS. So it's good for email addresses. I can fire up an identity server on, say, arisphere.net, my personal domain, and it can be the canonical naming server that declares how my email address is going to be mapped into Matrix. And it's very similar to Webfinger or that sort of class of technology to let people who own their own domain go and publish how they want to be contacted. So that's looking pretty cool, and honestly we need to sync with Max and find out where his implementation's at and trying to work out how to incorporate it with the Matrix spec. The alternative direction is completely opposite. You go off on a blockchain style direction to have some kind of distributed ledger where you don't put the attestations to say who is who and map the whatever identifier it is. And the problem there is that everybody who has done it doesn't seem to really solve the problem of working out how to trust the attestations. So it's all very well to have your funky decentralized database. You need somebody out there to actually validate and vouch and say that Amandine's phone number is actually the one that she owns. And do you do it by SMS? And if so, which SMS provider do you trust? Or do you do, basically the problem of how you stop me randomly publishing a record on a mail server, on a blockchain that says the Bill Gates of Microsoft.com points to @matthew.matrix.org is effectively unsolved still in a robust way. Perhaps Max from Keep.io will go and explain how they're solving it in his talk in a few minutes. But basically, those are the 2 different directions that we've been looking at. And we're honestly hoping that somebody else is going to solve it because we don't have bandwidth to do it, and it's nothing to do with Matrix at all. This is a very generic problem.
We also have a solution to suggest secret share.
Oh yeah. Is it?
It will be within the.
Oh, your one, of course. Yes, of course. Yes. Well, in which case we can have competing standoffs between different decentralized identity models. There's also the Scuttlebutt one. Are you familiar? Is anybody familiar with secure Scuttlebutt? Yep. Cool. So they have a really fascinating one where they basically crowdfund or crowdsource the whole identity thing and say that if you mention somebody, you are intrinsically validating their identity, and so every time you mention someone, you're basically publishing that identity mapping. I think that's awesome because there's no. It's probably, is it the same as the second share one, or?
Not exactly, but it's interesting.
Yeah, I think the problem obviously is limited to the visibility of your social network. So if some random person comes up and says, yeah, of course I am, guys, I am, because look, random person, you didn't know mentioned me, it's not very good. But within a kind of closed social network, it's great for being able to assert who people were. And I was talking to the guy who writes Secure Scuttlebutt in Berlin, actually, last year. And he said, yeah, people don't realize that basically Secure Scuttlebutt is a distributed key PKI system more than anything else, due to this idea that people literally every time they send a message go do an attestation. That's probably all I'm going to try to improvise in 5 minutes on decentralized identity. But cool, thank you everybody. I think we'll have a break before we launch into a series of much quicker and probably less boring, hopefully less boring talks from folks from the wider world. Any questions before we break on Matrix in general? Or no? Perfect. Okay, let's go and head and pizza for a few minutes and then get back here in 10 minutes or so. Thanks. Yeah, something like that. We had a big argument about federation versus these wonderful conversations.
You took the federation to the maximum of usefulness and much respect for that. I've never seen such a solid federated system.
I also agree with you that it's got,
changes no longer have to figure out how to solve it might actually just give it we failed to change the world. Look at all this stuff.
Once we have capabilities, right? I'm wondering whether if it's using Jitsi, I'm not sure Jitsi that has. Maybe it's using setting up the same way this thing is actually setting up the Hangout. That's funny. It's going to be
using Hangout.
So yeah, when you put like you then say I want to broadcast there is Hangout. I think it's going to be using Jitsi Hangout.
The reason I say is
Yeah, I need to be more aware of the technology behind it. Especially when you're
wow. I don't know what I can say about this. Like 5 minutes.
Yeah, it's not state conference yet, right? And then when that day comes,
you get extra job from
That's because my life is
Oh, no. The thing that I announced, that was no, I know I just thought we should mention something related, so I just hit the reply button. But it wasn't really that related.
Okay.
Okay, everybody. We resume.
I guess start off with like a idea. Yeah. I can go to college. Yes,
I agree. Okay, everybody, continue. Ladies, gentlemen, please take your seats.
I know you from somewhere. You were at Cambridge State with me. Which college were you at? Pembroke. You studied computer science?
Eventually, yeah.
Maths first?
No, I didn't.
No, Tim Fields.
Yes, I did. I used to work.
Okay.
But not through Cambridge.
Familiar.
It's some kind of Oxbridge.
Yeah. Or just Cambridge, yeah. Okay.
Okay, everybody. So I forgot to introduce the structure at the beginning of this, but basically the idea was to have me and Amandine rabbit on for 45 minutes, have a break. Then we've got three much shorter talks from Andy here, and from Carlo, and from Max there. And then we'll have another break, and then to finish it all off, we'll have Jack from Talk Dance, who is hopefully hiding somewhere. Hello, Jack. Thank you for coming to kind of provide the bookends to the evening with exploration into the parallel worlds of Polkadot, which kind of seems a bit like Matrix for blockchains.
It's more like that than what you're talking about.
Yeah, it's kind of fun. Anyway, cool. Over to you.
So, hi everybody. As Matthew said, I'm Andy. I will talk to you about my Matrix rocket jet bridge, but first, some questions. So, who in here is a developer? Like code on a daily basis? Okay, quite a lot of you, that's cool. Who uses Matrix on a daily basis? Also quite a lot. Who knows what an application service is in Matrix? Not as many, because if you already knew, I wouldn't have a topic to talk about, so that's good. So who am I? You can reach me on Twitter, on _Exul, if you have questions later, or of course on Matrix at exul.org. I work for Panther.ch, which I mentioned because they paid my flight from Zurich to Berlin, which is really nice. They paid me to create those slides, so that's great. Nice company. And as a hobby, I started to develop Rust programs. This is my first Rust program, the bridge. What I'll talk this evening is, what's the problem? Why do we need bridges, and why is it such a great thing that Matrix has this built into the protocol? What is an application service? How does it work? And then the tech part of it, what is it under the hood? And mistakes I made why I built this application service. So if anybody else of you wants to write one, you don't have to do all the mistakes I already did, which caused some delay on progress. So first, what's the problem? You know, that could be anybody's mobile screen probably. So you have so many apps, one for your friends, one for family, for your artificial friends, for your friends in Asia, for the crypto community. There's actually an ICQ app. I Googled that on the App Store. There is an app for ICQ for those who are a little bit older and know that. Then there's one for business, there's the one for the cool kids, and there's the other one for the crypto community that are on the other chat. So yeah, I don't want to have that on my phone screen because it's just not fun. So here is where Matrix comes in and helps us for this. An application service on Matrix can be many things. It can be a very simple bot. So imagine that you have an RSS feed and you want to get news into your channel from this bot. So every time somebody publishes something on a feed, you get a message in the room. That's really simple. But then it can be a bridge. The one I will talk about is a bridge from the Matrix network into the Rocket Chat network, which is just another chat platform that is quite popular these days, which is open source and built with JavaScript. And it's basically just something like a client that hooks into the whole protocol and uses it. So what type of bridges are there? Because I will talk about bridges in Matrix. So there can be bot-based bridges, which means you are in a room on Matrix and you bridge that, let's say on Rocket Chat, but there's only one user, and whenever somebody on Matrix speaks, it says bot Matrix speaks and says blah blah, which means you lose the whole context of who is speaking or need to add this to the message, which is not so nice. But it's a simple kind of bridge to build. Then there are other chat platforms that have bot APIs where you can actually create like virtual users. So it's not that bad because then you can create virtual users on the other network and identify the people that are speaking there. But it really gets fun when you start with pocketing bridges, because that means that when you have a user on the other network, let's say Rocket Chat, and I'm talking on Matrix with this bridge, the people on Rocket Chat will not even notice that I'm using Matrix, because I will talk with my native account on Rocket Chat, which means that the bridge has to know my credentials, but it also means that you can use whatever you like, and people will not notice that you use Matrix. So we can go one step further and have a double pop bridge, which means the bridge doesn't not only control the user on the remote network, but also the one on Matrix. So if you accidentally open Rocket Chat because you're so used to it and speak there, it will, on a matrix side, speak with your matrix user. So then you have buffeting on both sides. There are some other bridges, which I'll not talk about because I think they're not relevant currently for my talk. But there's also different types of rooms, because what happens when you bridge something is that you have one room on matrix and a room in the remote network. So there are portal rooms, which means you have Slack, for example, and you have matrix. So it's literally from one room to another, it's just one door, and that's it. So basically, the ACLs and everything is usually then provided by the remote network, because you just bridge one room. But you can also have plumbed rooms. For example, Matrix HQ is bridged to Gitter and Slack and IRC and probably something else as well, I don't know. So it just means that one room on Matrix is bridged to many rooms in our networks. And in this situation, usually Matrix provides the ACL and the rights for everything. So how is the flow? How does this work? It's really simple. You have a client on Matrix. I write a message. It goes to the server. The server has some kind of hook, forwards this message to my application service. The application service sees, okay, that's a room that is bridged. So let's forward it further to the Rocket Chat server. The Rocket Chat server has it as a normal message. The user sees it on the client, nice. All the way around, somebody writes something on Rocket Chat, it goes to the server, we have the hook, goes to the application service, goes to the Matrix server, and goes to the client. Wow, that was easy, right? So there are some nitty-gritty problems here. One is, what about users? Because if you bridge a Matrix room to Rocket Chat, there are users on Rocket Chat that don't exist on Matrix. So you have to take care of the user. When a new user speaks on Rocket Chat, you have to create a user on Matrix to do that. Luckily, Matrix has some really cool mechanics here, because if you would have to register a native user, you would have to create some random password and keep track of them and then send credentials every time, which is really bad. So there is an application service API, which gives you some nicer ways to deal with this. What about loops? So let's say I post a message on Matrix, it gets forwarded to Rocket Chat, but then this is a message on Rocket Chat, so we have to forward it back, right? And it goes back and forth every time. So we have to kind of detect loops, because otherwise it's not fun. The name changes, because usually chat networks have hooks for messages that forward something to you, which is nice. But in Rocket Chat, for example, you can change your name, but Rocket Chat doesn't notify you about this. You can only find out when pulling. So you have to kind of do some hacking, and when you receive a message, you have to check if the name is the same, and if not, then you have to change it and stuff like that. So that's not so simple. And then different features. Matthew mentioned that currently Matrix or Riot doesn't have reactions. Rocket Chat does. So what do you do when a reaction happens on Rocket Chat? How do you forward that to Matrix? There is no ideal solution currently. So when you write a bridge, you usually have to deal with things like that. Then the tech part. So now we know what a bridge is, what you can do with it. And on the tech side, it's really simple. So you have a REST API. Matrix is basically a whole bunch of REST endpoints. It doesn't have to stay with REST. It can do whatever you like, Captain Proto, Proto buffers, but the current spec uses REST and JSON. So most developers know how to do that. Then you have some kind of hooks on both networks, so you can register a bridge, which means that Matrix will forward you events. And Matrix does a really good job here, because it does not only forward you messages, but anything that's happening is an event. So a name change is an event. I don't know, an avatar change is an event. So from the Matrix side, you really get everything that's happening. And then if you are familiar with JavaScript, for example, there is even an application service framework that helps you really to build those kind of bridges. So a basic Slack bridge you can build with 100 lines of code with those frameworks. Sad enough, I'm not that good at JavaScript, so I built in Rust, which means a lot more work. There are also client SDKs, but you can just use the client server API with those additions from the application service, and you're good to go. depending on the language that you use. Now, the mistakes I made when I started to write the service. So I really just wanted to write this because my company is using RocketChat, but I like Matrix. So I thought, well, let's use Matrix because RocketChat client on mobile sucks. Should be not that hard, right? First mistake I made was I didn't really think about what kind of bridge I will write, because at that time I didn't know what kind of bridges exist. And it makes a big, big difference if you write a bot-based bridge or a double pop bridge. So you should get that right when you start. Another thing is I didn't think about persistence up front, because when you bridge one room to another, you kind of have to remember which room is bridged to what, right? So the bridge has to store this information somewhere, and either you use a database, or you come up with some kind of fancy name schema that you can stitch together and use that. And I started with database, which would not be that bad, but I didn't like to write all that stuff, because when you lose the database, then you don't know which rooms were plumbed together, so that's bad. And I started a complete rewrite where I basically tried to avoid storing things on the bridge and just store everything in Matrix. Then I tested against my database. So when a user was registered, I wrote it into the database, but I didn't write my test so that I tested against her, because that's where the action is happening. And now I started to accidentally write like a home server implementation for testing, where you can hook into the events and see, okay, was this message sent to the register endpoint of Matrix, or was there an event sent to the message endpoint, or you can just return errors because you want to test your error case. So that's really helpful if you have something like that. But it also makes it quite hard because it's a lot of work to implement a home server. I only implement the part that I need, but it's still a lot of work. And now that I talked about it, I'll show you how it works. Demo time, what could possibly go wrong? Let's try that. First, that you see what's needed. So on the right side, this is my Docker image for RocketChat. On the left, this is my home server, and this is my client. And here is my bridge running with login. So now I should be able to fire up Firefox 2 times. So here I log into RocketChat. I hope I don't. I'm not started yet. Ah, thanks. Cool. So this is my test user with my secret password that you will see in a second. So don't remember this. So this way we can see a bit more. So we start by inviting a bot user into a channel and start a direct chat, because you need some kind of control room where you can say what is bridged with what. So So this is my bot user, which is configurable per app service. So I invite him, create a new chat. I will start a new one. Here. Oh, I did something wrong, which is bad. Okay, let's take the existing one. I have a backup plan here. So basically, you create a room where the user sits in, and then you can just say help. Tell me what I have to do. And it says, okay, cool, you're logged in. I did that already. Login is basically just saying login, user, password. And I also created the REST endpoint that you can do this via curl, because if you do it here, it'll be stored on your RocketChat on the Matrix server, which means your password will be on a Matrix server, which is not so nice. But once you're logged in, you can say, this is my rooms. Now you can go here and say, okay, let's create a new channel because we want to. Let's call it Berlin. And let's invite the test user here and create a room for us. So now we have a room which should hopefully show up on that side, which is Berlin, which is in italics because you are in that room, and there are other rooms like T4, which the user is not in, and which I don't allow him to bridge because I really want to make sure that the user that can't bridge a room that he cannot see in Rocket Chat. So it should be everything like in Rocket Chat. Now we can say bridge Berlin. I should get an invite in a second. Here it comes. Where the bot user now created a room. So it checked if the user is allowed to bridge his room, created a room. I can say accept. I can go into the room, and I can say hello from Matrix, and it shows up on the Rocket Chat side. And I can say hello from Rocket Chat. Okay. So there is a bit more. So there are direct messages on Rocket Chat, which are a bit more tricky because a direct message is something that you can initiate on Rocket Chat, but I don't want to bridge every user for potential messages that I get from them. So I kind of auto-bridge them if you direct message the user that has bridge stuff. So if you say hello here, it creates the room automatically. It says, hey, there is a direct chat for you. It's from the user 010 on Rocket Chat. And you can say, I accept the invite, or not if you don't want to. And say, hi. And then it works as well. So this is the kind of stuff that makes it hard because there are lots of edge cases that you have to handle when you write a bridge. So set up a basic bridge is really simple, but to have it fully functional with, it also works, by the way, if we do hello code, and it gets translated on each side. But there are all these kind of features that you have to map from one network to another, which makes it hard. And I really hope that more users that write bridges don't give up after 1 month or 2, because there are lots of bridges out there that just do messaging a bit maybe, but don't deal with other stuff. And that makes them mostly unusable. So I really try to make this work properly. Which brings us to the last point I have. Is this production ready? Of course it's not. So, by the way, this is our cat, really. My wife took a picture of her for putting it into the presentation. So, no, it's not production ready. It is stated in the README on the very top, because there are some additions I like to get out first before people do that, because once you start using a bridge, it will create rooms, it will create names for your rooms that you cannot reuse. So I really intend to get it right first, but I hope I'll get there, and then I will write a message somewhere that people can actually use it. That was my talk. Thank you very much. Any questions? Yes?
How did you like writing HTTP stuff in Rust? That's a mess.
No, it's not that bad. So what I use in Rust is I use request, or it's basically curl. And I use iron as a server. And yeah, I don't use the async stuff yet, so that might make things a bit more difficult. But besides from that, it was quite okay.
All right.
More questions? If not, then room for next speaker. Awesome. Thank you, Andy. I should apologize on behalf of Matrix for the missing bit of the application service API, which is a bit that allows you to log on in a single sign-on kind of video, so you don't have to ever put your passwords in the Matrix room. So that's the correct workaround for now, but the idea is that you have an event type that you can use to log in properly to avoid dramas like that in future. Anyway.
One addition, fix the spec.
Yes, yeah, and the spec is horribly so.
You got a PDF.
You got a PDF, perfect. In which case, how do we do PDFs of USB sticks? This one? Can we use
we got a PDF on a USB stick. Just put it on the computer. Yep. Well, that one's being used to live stream. If you can put it on this one. So whilst we're messing around and getting the slide stacks, I should introduce Carlo.
Max had this
randomly 3 years ago, basically we started. And so there's a mailing list, some people might know, called Modern Crypto, which is a bunch of crypto freaks talking about messaging stuff. And I think I sent a message out there saying, hey, Matrix is a thing. This is incredible. It's going to change everything. And the first person to respond was Carlo, who said, no, you're doing it all wrong. This is a disaster. You're reinventing the mistakes we made 10 years ago. And we had, I think, a relatively creditable flame war of about 30 messages. Each one sort of started off 10K, then 20K. By the end of it, with all the quotes, it was probably about 200K of text message. I assume that we're both being kill files off the mailing list by everybody else at this point. We probably should have taken that off list. But anyway, it's a great pleasure. I can introduce Carlo to explain.
So we actually met for the first time tonight.
Indeed.
Yeah, I was just on a little time travel there with your presentation, because it's the kind of stuff I had been hacking up like 15, 17 years ago, like doing gateways to ICQ and XMPP. And but there's a difference. Notice again. Oh, yeah. And the design of the protocols and the subsystems, I always try to change it so that at the most basic level it would be the most natural possible. So in Psych, if there are some new messages that you need to do, like you're gatewaying to some other system that generates messages that you don't have on metrics, well, in Psych I just invented new messages. And I just make them appear in a suitable way in all the implementations that would show them. And so we could map any XMPP, IRC, or ICQ message type, where you would just map it to something native and expand the horizon. And for the addressing, the gatewaying for the addressing, in the case of XMPP, we just had XMPP URLs natively used in Psych. And for the case of IRC, we would just use the IRC network name as a protocol, like freenode : nickname, and then you can just message anyone. And then the server can automatically assign a nickname, and so you can just talk to ghosts all the time. Okay, problem with IRC, people just change the nicknames, and especially if IRC doesn't tell you anything about it. But and well, in that case, I then took the IRC server implementation and changed the IRC server implementation so it would make sure to tell me everything. And I also changed it to accept URLs natively in IRC protocol. So you could use priv message XMPP : something and send a message to a Jabber user from an IRC natively, because it would be sent to the Psych server, and the Psych server would gateway it to the Jabber. But yeah, stuff we did, and then it died away again. How can I switch to a lot of pages later? Like the divider. Yeah, but I've got a whole different presentation here, which doesn't.
What is not your presentation?
Is not the one. It is my presentation. It's just that I had the other presentation in front. No, it's correct. No, everything's fine. I just had to skip all those slides from the other. Okay. So yeah. All right. So Psych was the protocol I was talking about. That's previous work. And if you like the /me command, do you have my /me in metrics?
Yep.
Okay, great. I invented that. Okay, secure share is the one we're talking about now. And another thing is the certificate patrol for Firefox is quite useful right now, since they broke WPA2 for Wi-Fi. So if your Wi-Fi gets hacked, and you have this running, then your Firefox would warn you that somebody's man in the middle in your encrypted HTTPS connection, so you might find that. But let's get to the real stuff. So the different direction that we took, so Matthew went on to design and implement the most advanced federated system the internet has ever seen, so great job. We disagreed because right there he started with federation at the point when we just got to thinking, oh my goodness, this federation thing will never work out, because there are sociological problems with people trusting the server that their boyfriend set up or something, or their sysadmin or whatever. There are technological problems of scalability, of a tendency to centralization. All the federated systems we've seen so far at a certain point started being Googleized or Facebookized, and then you would have this huge node run by a company, especially when the protocols are not designed well enough to scale. Then they end up working better in a cloud architecture of a single company rather than as a protocol themselves. And that's why mail works much better if you use Google Mail instead of etc. And that's not the way it should be. And we realized that we need a distributed technology. That was like around 2010, and we started looking for technologies out there, and we heard of MateSafe, and there was RetroShare, and they all weren't really like. And we found GNU-net and found it the most reasonable, but we didn't expect that we would be working on it another 7 years to start using it. In the meantime, this is a picture giving an idea how we're trying to do a different kind of internet. So the idea of GNU-net that started with 9/11, essentially, the original inventor of GNU-net. He saw 9/11 happen and thought, I think we need a better internet. He was slightly ahead of time with his thinking, but on the other hand, we're 16 years later and we don't have a better internet yet. So, and what would the better internet be like? We have some fundamental architectural problem with the existing internet. Not only that several things in the technology are kind of broken, but also that some layers, some problems aren't really solved at all. Like, how does the internet scale? In the current architecture, it only scales if you have a cloud or if you have like BitTorrent. And so what the internet should have is a low layer distribution mechanism. What it doesn't have is a way to authenticate an identity, have a social interaction between people, have a layer that models social things naturally, well, which means that it always ends up somewhere in Facebook or Google or something up there. And a social authentication layer would allow any application to be just, application, please do something for Jack. Please connect Eva. Please tell it to Robert. And the internet doesn't allow you to do that. You always have to find out which is the current IP number, and even then, you can't connect to it directly. And then a thing that has made the surveillance economy kind of inevitable is the missing payment system. And ironically, there was a historical moment in the 90s when there was micropayments had a chance of making it, and but it went wrong, and now we are everybody chose to go for advertising, and advertising became a surveillance machine. So it is fundamental to have a micropayment layer inside of a better internet. But oops, okay. Come on. it's only showing half of the screen actually. It's not.
This thing there.
Like if I go like this, it's actually longer. Is there a way to fix this?
I'll have to zoom in.
Or zoom it like that?
Yeah.
Oh. Okay. Okay, so why is the site protocol now? Okay, guess I'll get to this later. So why would it be interesting for metrics? Essentially, if everyone has a GNU-net node on their devices or anywhere close by, then you would have a distributed system. It's similar to all the blockchain technologies, only that the blockchain only do a very small portion of the distributed problem space, and we can need it in a much more generic and open way. And what SecureShare does is trying to implement a social network on top of GNU-net, but so that means on a basic level, we do distributed pub subs, publish, subscribe, the publish, subscribe approach paradigm. Is sufficient to actually model all kinds of social relationships. And if you have what the site does with the pub sub is it has two kind of information in each pub sub. It's on one side it has messages happening on a chat room or something, whatever it is, and those messages can disappear with time. But there's also a distributed state, which is maintaining where you can put storage. You can store things inside that can be changed over time by the other messages. And this that's very rudimentary, but it's kind of similar to the blockchain concept. And it allows you to model all kinds of things you are interested in, and a lot of internet applications can be mapped on top of this. And that also means for Matrix, instead of having the big servers that federate between each other, you would have distributed chat rooms that somebody initiated a chat room, and then it's traveling all across the network with people participating.
We're going to have to probably wrap up at this point, Carla, I'm afraid, because we've got to get through to other talks tonight. Although I'd like to point out that we would love to use some GNU-net and ANSI, for that matter, as a federation mechanism of Matrix. We're not in any way locked onto HTTPS and conventional federation. And if we could go and run this stuff client-side and do it peer-to-peer, then hell yeah, basically. And so I've spoken a lot to Christian Grotov, who's, I think, is running GNU-net at the moment, about the idea. And there's basically a lot of interest in us using matrix-style semantics alongside Psych. So ironically, it all converges in the end. But it's very cool stuff. Thank you very much.
Yeah, sorry, I got lost into some details. Okay, I'll just some basic points that I wanted to say about identity and everything. It's if you have a good modeling of the social graph, distributed model of the social graph, being based on that kind of technology, gives all the applications the possibility to know who your friends are, to work with information about who other people, which other people you trust, which other people you add to your network. So if everyone in your social network, for example, agrees that Jack has a certain public key, then you might not always need to confirm the public key manually yourself. Like the identity itself is a social thing that grows. Like, is it connected with your thinking?
Yeah.
So we just need to get set up for the next one. Max, if you get to
put the Apple TV.
Well, I reckon that's what it is for people to come and finish this afterwards. So we had a like 5-minute slot, and we're a quarter of an hour in now. So
Yeah.
sorry.
Okay.
Yeah, you can just. Cool. Okay, I'd like to introduce Max, the CEO of Keep.io, to talk, or just Keep, was it Keep? Oh, how do you?
Keep.
Just Keep, to talk about decentralized identity.
Right. As soon as I finish that.
And the plan here is that we'll probably go straight into Jack from Bulk after this, if that's all right, Jack. Okay. We can have a quick breather for people to grab emergency beer, and because I think, correct me if I'm wrong, we've got to get out. And we've got to get out of here around 10 at the latest.
Yeah, 10:30.
So 10:30, okay. So we've got a little bit more headroom than I thought. But
As soon as I connect that.
okay, whilst we go do we know what we need to do to make this work?
Sure.
HTML2. You're probably better at this. I'd like to thank Carly very much for talking. Sorry, do we have the concept of the hook in Germany? This is the thing in England, sometimes if you're running out of time and somebody's on stage, and in Victorian times they literally went and took an enormous hook and went, literally it was the thing, almost forgotten about it. So I'm sorry for having to use that hook, but otherwise we're going to get kicked out before we finish. But yeah, it's like it's very cool, and please come and talk to Carl about it. We should continue talking about how to get it run on top of, or get Matrix on top of it. What are you going to tell us about Philip?
I'm using laptop, right? I have it.
Oh well.
I have to boost things, so it's showing. Okay, while he's fixing, I just started. That's fine. I need my pictures later. Okay, so what we talk about tonight is decentralized identity and why this is important, and not only from a technology point of view, but also from a business-wise, because I'm not a tech guy, which means every question you start with, how do you, I won't answer. So in the end, what we learned, I'm normally using a slide from IBM, because IBM is trustful and proper, and we believe it's IBM, it's still there. And they saying actually that our system and ideas of digital identity changed over the years, as you can see there, and that we have to do it again, because otherwise the system will collapse, will broke actually. And why is this? Therefore, you have to understand that the fundamental principle of economy is the contract and the parties, which means every transaction we do is based on this principle. And if we digitalize it, making the contract, the content digital, as well as the party, which is nothing different than the identity, then we have to be sure that we can't manipulate it. And that's actually the problem that we have so far, that we don't have verified identity. And the reason for that is quite simple, as our current technology and the way we do it is actually working like that, that we have tons of different databases that host unverified identity attributes. And identity and digital identity is nothing different than a sum of identity attributes, which means depending on the situation, on the use case, on the login, we have different attributes. one example. If I go shopping in an online shop, I need as attributes my name, my address, and my credit card data. That's it. But if I want to do car sharing, I need a verified driver's license as well as my age. So in both cases, it's a digital identity, but the sum of attributes are completely different. And that's actually the problem with it. And now you could say, okay, then it's quite easy. What we have to do is just, we have to put it on the user. We have to bring all the attributes to users, because then, like in reality, if the user logs into a service, into a database, he can transfer his identity attributes. And that's actually the problem we have. Because if it's on the user, he can manipulate it. And that's the way we have to change. But on the other side, we need it, as we have to have verified identities in a working system, that it makes it easy and secure at the same time. So I just run through the problem quite on a meta level, because I think you're much more into detail there. So how are we doing it? So what Keep basically is an layer, is an infrastructure that connects authenticators with all kinds of systems, where you can transfer identity attributes. Therefore, you have to know, nowadays it's like that you have identity federations, which means some companies are saying, okay, we join in terms of digital identities and share the same identity. For example, if you use the single sign-on of Facebook, you use the definition of Facebook's digital identity. The attributes Facebook can provide, you will get if you put in the Facebook login. If, for example, if you want biometric attributes, it's not going to work, because Facebook, well, officially is not storing biometric attributes. So, and this is not just a problem when it comes to tech, because the whole system has to together define the digital identity, which consists of different attributes, but also a legal problem, as we are not allowed to share without a contract any user data without permission. If the user actively would decide, like we saw before, okay, I share with you this part of my identity, this attributes that you need, then we don't have a legal issue. And that's actually what Keep provides. Keep enables any company to create a universal login, a single sign-on, as it stores the identity attributes on the user. Back to the question, how do we do it? Basically, it's quite simple. So a login, a database that, and from our point of view, is just a resource, asks a user for specific attributes. Therefore, the user needs a wallet. This wallet has to be on an HSM, so a hardware secure model, which is, for example, in the iPhone, so that we can make sure that we have an API. In terms of that, then there's a private key and we can't somehow get into it. So once he asks for specific attributes, what the wallet does is nothing different than redirect these attributes to the specific authenticators for an attribute. For example, in Germany, we have this ID Now, and they are validating driver licenses and ID cards. So if, let's say, Airbus needs a verified driver license or an ID card, it asks the wallet of the user, and the wallet of the user just redirects this request to the authenticator, which is in this case ID Now. And ID Now will now verify my ID card and send it back to the wallet in form of an cryptographic badge with a signature. And this will be maybe have a time slot for, let's say, 2 weeks or 1 week. That's not important. The resource owner can decide. And what the wallet will do now is just redirect this information to the resource. And through this, you now have a decentralized storage of verified attributes that the user can use for any of course, connected single sign-on or login. So as I described it here, you see we have a login. And for example, we need for this login 3 different attributes, like a validated email address, as well as the ID card, and this is the interesting part, also the customer card, of course, because there's a profile of this bank to log into it. And as all of them are verified at the beginning and stored here, it's just one click for him. What you see there is that on the one,
What is it stored?
Sorry?
What is it stored? All this information then?
This information
Yes.
here is stored in a cryptographic batch in the wallet here. That is connected to the HSM. But the verification process will be done in their systems. So that's the decentralized part here, that you send it to them and in their database, and that's actually what I'm.
But are you able to decide which data you want to share, or how does it work?
The user sees the user
that
sees here which kind of data he needs for this login, and if he clicks actively on the login button, then the information will be shared. If he doesn't, it won't.
Okay.
So, and that's actually the interesting part. As you can see here, the bank, for an example, is on both sides. On the one side, it's the login, the resource from our point of view, but on the other, it's also an identity provider, an authenticator, as it already have information of the user that it can transfer to itself. Sounds a bit tricky, but in the end, it's when it comes to identities, it's all about attributes. If you look into detail, we can put keep into different layers. Like you see here, on the lowest layer, we have the authenticators I mentioned before. So we have classic authentications, like all kind of factors that you want. You can connect any kind of it as we provide an SDK. As well as were described before, attributes verificator, like the bank could be one, as they already stored them. And also, of course, payment can be also part of the digital identity. The next layer that we have is, like I described before, that what we have so far are identity federations. So, like I said, a bunch of people, a bunch of companies say together, okay, we define a digital identity like that, those attributes. What we do with Keep is actually the other way around. We say, you don't have to define, you just have to define what how the factors are transferred. And that's why we call ourselves an identity factor federation, as it's only, the definition is only based on the factors, not based on the whole federation system. As I said before, we have a solid infrastructure and we need an HSM support, because otherwise it's manipulated. One step above, the next layer is actually for companies so that they can use Keep as easy as possible. Because, of course, on the one side we have the security issue, but on the other side we have also the convenience part. Not just for the user, but also for the company, because if it is not simple for the company, they won't use it. So we actually used an analogy that we said, okay, let's do it the same way like the App Store does. Bring all kind of authenticator to one marketplace that the companies can pick the ones they need, so that they know what kind of authenticators are there on the one side, but also on the other side to create a flexible market. So depending on the identity attributes you need, you are willing to pay more or less, depending, for example, on the security level. To configure them as easy as possible, we give them a workflow editor where they can just drag and drop the different authenticators, because they don't want to code. They just want that it works. And that's the new part of it, through that they create dynamic. The system becomes flexible. Because if you see that you have a lag, or that you don't get the information you need, or if a new regulation comes out, you can change your login within a second, because you can just go to the App Store, add another authenticator, put it in your workflow, and it's done. And last but not least, we are working with all kinds of systems. So any identity access management that's out there, so far as we know, can be connected to Key. As well, we're working with any standard that is out there, as well as any SDK. So our main goal was, in the end, to create a layer for digital identity that is open, an open infrastructure that anybody can use and can use for their specific use case. Because as I said at the beginning, the biggest problem with digital identities is that depending on the login, you have different attributes, which means logins are context sensitive. Last but not least, as I described before, you have this wallet, which HSM support, and this as the information and the data and the attributes are only stored in this wallet. You create data sovereignty and privacy, as even Keep as the infrastructure provider has access to the wallet. And only if the user actively decides to log into somewhere, he shares the attributes that are needed by this login. And he sees it. So we make the transfer of our identities or part of our identities obvious, and you can see it there. On the other side, you have the companies that can still use their own login because they only have, of course, to connect to the infrastructure, but still work on their same system. The identity access management they're using will still be the same. The databases they're using will still be the same. We just provide the transfer of the attributes. That's so far from my side. I'm happy to answer all the questions except the house. Thanks.
There's a whole bunch of company logos in your presentation, like Siemens and Adidas. Are those actually your customers right now?
So it's just as an example, of course. We started 3 months ago. So we developed the technology for 1.5 years, tested it, and made the concept. And since 2 months, we are under the radar working. Sorry.
Is it built on top of any blockchain or?
Well, actually, we started
with privacy.
And we started with blockchain actually, and then got some problems with that. So we developed our own protocol, which is near to the blockchain.
What were the problems?
Well, actually 2 things. On the one side, it's you have kind of very specific information. You have sensitive data, which you don't want to distribute through the whole system, which means like can't put it into the blocks like you want it on the one side. Of course, there are solutions for that we could use. From the other side, the protocol we're using is way faster and in terms of complexity, way easier than the blockchain. So we said, okay, if we have the benefits of it, why shouldn't we use it? So in this, to put it very, very general, this transparency part of the blockchain is in this term not helping.
What's the main difference between you guys and Civic, for example?
Well, in the end, it's really the process that it's open, that you can really use it for any use case. Like what we were describing right now is just the human part, the human login. But of course, this is working for machines as well. It's the same way, because as you only need the HSM, it doesn't matter where it is stored. So the wallet can be put anywhere, and it also doesn't have to be our wallet.
So is it storing at the device, or where is it stored? The whole data, or where is it?
That's depending on you. For example, you have servers which HSMs, so you can put it on a server, for example, the wallet. You have smartphones, you can put the wallet on the smartphone. You have machines, you can put it on the machine. Anywhere where there's a storage with an HSM, you can put the wallet on it. And anybody can develop it. So as I said, it's an open infrastructure. Anybody can use it. Okay.
Cool. Thank you very much, Max. If we grab emergency bit and that gets up, there's a little bit of cold pizza left, which is amazing in and of itself, and we'll be up with Jack in a few minutes.
Hey, I don't read it. Okay, you're showing everything.
Yeah, I was going to say, can I show different things on the
I don't know how to.
Very nice.
Like demonstration. Yeah, no,
yeah, so
I tried that wallpaper.
as a pressure.
No,
Oh, he's
The other way around.
Yeah. Oh, yeah. So this is like still I didn't touch anything. You've got the old one, right?
Jack, that's the shit you need for no one to do your presentation.
Okay.
Yeah,
that sounds good.
Jack, we can totally share roads. So
well, I don't know. Oh, you
Everybody, every time you can Jack from the live row. So introduce Jack. Hello, Jack. Thank you for coming. Indeed. Who has very, very kindly come to us from Polkadot, as you can see, to tell us, well, or something. Introduce yourself. I'm going to screw it up. So, sure. Beard up. Okay, cool. I'm Jack. I'm from Heritage Technologies. I'm here to talk about Polkadot. Well, I kind of said this the wrong way around because this is my name. Normally, I would have my Twitter account down here, but I'm trying to avoid putting that out in a special capacity. So,
Other people can see from the
yeah, that's right. So I'm sure if you're old, like I'm not, you'll remember old web, like 90s pre-Facebook era web where just you had a bunch of HTML, or DHTML, or whatever it was called back then, and you just had some server, and if you wanted to serve your own content, you have to set up your own server, and everything was sort of siloed off separately. Nowadays, we have what everyone calls Web 2.0, except people don't call it that anymore, people just call it web, because it's got that point, which is social media. So everyone creates their own content, but the hosting, the serving of this content is not distributed in the same way. The hosting is done by Facebook, or by Google, or by Twitter, or by MySpace, if you are, again, old. And what Polkadot and Web3 Foundation in general is here to set out to create is Web3, as the name implies, which is something which was sort of originally brought up by Gavin Wood, who you might be aware of if you're at all know anything about the blockchain space. Was sort of one of the original guys of Ethereum, and he really wants to bring the decentralized content, which we know and love today, and bring it to a more peer-to-peer, decentralized delivery system. And there are a few components to this. I think I'll get to. I won't be talking about some of the others. So Whisper and Swarm. This is it. There we go. My backup. But I'm here to talk about Polkadot, which, yeah, this is about Web3. Give it a second. I don't want to talk about them that much because I'm not here to advertise them on Parity. So, yeah, I'm here to talk about Polkadot, which is one component of these systems. It is a blockchain technology to end all blockchain technologies. I'll explain exactly why I can say something that's that dramatic soon. Okay, so the reason I'm talking about Web3 Foundation's stuff is because they are working with us to develop it. We will be the developers. They will be the corporate overlords, to steal a phrase. And sort of we are sort of known for developing blockchain stuff already. We developed one of the more popular Ethereum clients, although not the most popular. And working on it. And as a result, we've got a lot of sort of knowledge in the area, maybe not me specifically, I'm fairly about half a year. And we've got a lot of knowledge base and people who are very experienced with this kind of thing and want to see it expand. That's why I'm here. Right. Technology, the actual thing, Polkadot. I'm sorry, I'm not going to look you in the eyes too much because I'm looking at my speaker notes. I don't know how much you guys know about blockchain, current blockchain at least. So stuff like Ethereum and Bitcoin are the two biggest ones. Monero is up and coming, Zcash. Probably have heard these names floating around, Bitcoin especially. And they all share a lot of problems, which specifically are these ones. Or they have some other ones, but I'll get to that in a bit. So currently, all of them do one thing. Ethereum is a little bit more extensible because it has smart contracts. You can program transactions, but you can't really do anything else. You are stuck to proof of work, for example. You're stuck to precisely what happens when you transfer money. There's very little flexibility you have in Ethereum, and Bitcoin, Zcash, and Monero even less so. You can basically, it's money. You know, it's not a platform. It's not anything else like that. Also, all three of these are not super scalable. Bitcoin, especially, like I don't know what transaction times now are now, but like probably minutes to have any real confirmation. Which, if you want to pay for a beer, not gonna work. I know, I've tried. There is a place around here where you can buy beer with Bitcoin, and well, I haven't personally tried, but I know that there is a bar around here where you can pay with Bitcoin, and it's not happening. Also, heterogeneity, which basically, similar to the extensibility, each of these does one thing and satisfies the needs of one group. You don't really have different groups interacting over the same protocol unless they're different groups all like money. I guess there's a few of those. The Polkadot has solutions for these three. It doesn't have solutions for some of the other problems, so I didn't put them on the slide. So the reason that these problems can't exist is because at the moment in blockchain, everything's just a big blob. We have consensus, which is basically how to get the world to agree on a single state. So blockchain is basically just a database, right? They're basically a database that everyone shares the ownership of. You have some way to agree on the database while defending against evil users and users that are just crap. And then you have another thing, which is the whatever the blockchain does. So the state transitions, the way you get from point A to point B. So I give person X 10 Bitcoin, I lose 10 Bitcoin. Simple stuff like that. So the reason the Polkadot kind of solves some of these problems is that it has these separated into they're like siloed off from each other. We have the relay chain, which is the Polkadot itself, I guess, which simply gives you a way to agree on some state without really giving any opinion on what to do with that state once you have it. And then you have parachains, which are the sort of applications built on top of it. So the telling you how to get from point A to point B. And as a result, you can sort of have these different parachains be different technologies entirely. You can have Bitcoin implemented as a parachain. You can have Zcash implemented as a parachain. You can have Ethereum implemented as a parachain. In fact, you could even have another Polkadot implemented as a parachain and then have parachains on that one if you want, if you're crazy. But you can do more than this. You can also have private chains, which are in use today for like banks, whatever, who want to talk to each other without having to necessarily trust each other. Or I think, was there car companies? How was a thing to each other? Or energy groups. Like all of these, they have private chains where there's a set number of owners, and they don't want the outside world to see this chain. They just want to have some way to agree on the state without having to trust each other.
but they have really no way of accessing the outside world without trust, without some kind of bridge between the two, which is centralized. But because Polkadot has these parachains, you can use these as a bridge, either to a private chain or to a public chain. And there are some trade-offs depending on which one you want to do, and I'll get to that in a minute. So as a result, you can do this, and so you don't have to read. I'll explain. So if you want to, for example, so currently, if you want to accept money for some kind of investment thing on the blockchain, it's pretty legally murky because you have to have, there's accredited investment laws and so forth. So you kind of want to have some kind of connection to an identity service, like a bank maybe. And you can do this in a completely automated way without any centralization using Polkadot. But if the bank used proof of authority chain I don't know if I feel like I should have explained proof of authority. Do you guys understand what I mean by that?
Please explain.
Great, thank you for the cue. So the private chains that I was referring to earlier, where there's a set number of authorities that control the chain, but no single one of them has to have ownership over the chain. They still agree within themselves. But like essentially, you don't have to have any work or anything because there's not an infinite number of users. There's a set number of users, and you know who they are. And so you can just say, if this account says it's okay, this account says it's okay, and you have like some kind of voting system. So if the bank had one of those, you could connect that automatically in some kind of automated way without having to have any kind of centralized service like exists now of like passport checking or whatever. And then there's a bunch of other stuff like the third one you see is sort of probably the simplest use of Polkadot, which is just straight up an exchange. At the moment, exchanges super suck, and they are really easy for the exchanges to manipulate the exchange rates between Bitcoin and Ethereum and just screw you over in God knows how many ways. And Polkadot, at least if we screw you over, you can look at the source code and see why. But yeah, you can use it as an exchange. And an important part of this is that the chains, because of this relay chain, which has the consensus, you don't have to have each chain provide its own security. Currently in blockchain, the more users you have, the more secure your chain is. So Bitcoin, it's kind of only got a few users who have control, but like the more users you have checking that the transactions are valid, the more secure the network is. But if you want to buy some Kanye coin or some whatever else, something like some coin that no one's ever heard of, the set of users is very small, and as a result, it's very easy to game the system. Whereas with Polkadot, because you sort of have multiple chains connected to a single point of consensus, you end up with a you end up with the security of the whole being the security of the smallest chain. So if you have Zcash and Litecoin, this infographic was not made by me. I don't know why Litecoin got on as a large currency.
Gab wanted it.
Fair enough. Does he like Litecoin? Just going for your face. So you have to choose like a percentage of the CPU power to go to each one. So even if you have the same number of users on each one, there's only a finite number of cycles that can be run in a given second. And if you have separate clients, it's only inevitable that some of those cycles are not going to be spent on Zcash. You know, like so. Essentially, with modern blockchain, the more cycles are on a chain, the more secure it is. And so, if you silent them off, you have to choose which one has to be the most secure, or they're all less secure. Whereas with Polkadot, everyone works on the relay chain, and then the parachains are sort of innately secure as a result.
So that means that someone is going to be mining the Polkadot chain, or
So mining, I will actually get to this in a second actually. Mining doesn't really happen in Polkadot. It's not proof of work, it's proof of stake. So proof of work means the more CPU power you have, just working on hashing, the more secure it is. And therefore you end up with these miners who end up succumbing to the economics of scale. And what we use instead of proof of stake, so if you have money on the chain, you put money up, and if you screw up, you lose that money. And as a result, you don't end up with like economies of scale because you sort of have a linear amount of power depending on how much money you have, rather than an exponential amount of power based on how much money you have, which is how work works today. Right, and this is the technical stuff here. From here on out, I'm not going to be talking high-level markety wank that you see on a TV ad. I'm going to be talking actual technical stuff. I said TV ad, like we're going to be advertising this on TV. Okay. So what are these things? Relay chain and parachains. I was talking about this earlier, but I don't think I really satisfactorily explained it. So time to drink while I'm talking. So you got the relay chain is a message bus. Essentially, it's a decentralized message bus with a method to have consensus over what the messages are. It might as well be 0MQ, rabbit MQ, except those things require trust, because you have to have something to be the ultimate source of truth, whereas this has a consensus mechanism, and therefore everyone is the source of truth. Away from communism. So parachains are simply, they connect transactions, and they have some way of validating whether those transactions are correct. So it may be if Bitcoin, the network says it's correct, then it's correct, in which case it would be a bridge, or it could be if the numbers, the balance adds up, then it's correct, in which case it would be sort of a blockchain built on Polkadot. Like these things are not separate parts of Polkadot, they simply occur naturally from this parachain concept. I mean, if anyone's ever touched Ethereum and knows what smart contracts are, they're essentially smart contracts on what everyone seems to love to call steroids, despite the fact that kind of steroids don't make you useful. So this is the relay chain does nothing. It has some way to have stake, which is the method of securing it, and it has some way to achieve like a canonical ordering of messages, but that's it, and a canonical delivery of messages, but that's it. It does very, very little, and that is by design. Although it can still be upgraded by stakeholders, although honestly, my knowledge on exactly how you upgrade the relay chain is pretty fuzzy. So you have, this is what I was talking about earlier, you have more than one kind of parachain. You have open parachains, as they would be called, which is a blockchain built on Polkadot. It reuses all of the validation mechanisms that Polkadot needs already in order to check that it hijacks it for its own validation. Then you have closed parachains where they don't want anyone to see their data. So no one else can validate that internally it's correct. They must trust that it is correct according to itself, and they only decide whether or not they want to use that parachain's transaction. So something like a bank, they would want to do this. They want to use a closed parachain where they don't reuse validation. They just sort of give a yay or nay. And bridge chains have a very, very similar concept. So they would have validators that connect to other network, Bitcoin, Ethereum, whatever, and just give a yay or nay and various messages as a result, based on what the other chain's consensus says. So the chains, I was going to say the relay chain, but actually one of these is not on the relay chain, have more than one node type. So currently the way that nodes work is that you, essentially, if you run a Bitcoin node, an Ethereum node, etc., you do a whole load of work, and it basically makes it not easily useful for most people, because you have to check that the chain is correct at most points. If you want to do anything at all, because you end up with this like completely trustless society. So you have to do the work of the validators, and you have to also like validate each of the blocks, and you also have to check that other people's validations are not rubbish. And so as a result, most people just end up using centralized services, Mine for Wallet, Coinbase, Kraken, other ones also probably exist. And so in order to sort of separate this workload out and make it a bit more efficient and more parallelizable, Polkadot has 4 kinds of node. Validators just sort of check that the transactions are correct. They look on the relay chain and make sure that everything is in order and that there is some consensus. And to do this, they put up some stakes. So they put in some money. They say, if I succeed, this money will be protected from interest. There'll be interest. But if I fail, then I will lose this completely. And that is the job of the fishermen. They look out for where these validators have screwed up. And if they have screwed up, they give proof of that. And then they will get either all of or some proportion of the stake, depending on precisely how the implementation happens. None of this exists, by the way. I don't know if this is obvious. This is all just wishy-washy in the air dream time. And collators, moving on now, given this extremely late notice. Collators basically are validators, but for parachains. So they will collect. If you try and push out a transaction, you say, I want to give 50 quid to Bob. I'm rich, don't know if anyone noticed. Then you would say to a collator, I want to give 50 quid to Bob. And then they would collect that in and they would pass it on. This is currently the job done by miners. And it's this is kind of what leads to a lot of the inefficiencies and the centralization of stuff like Bitcoin, where because the miners get to choose who gets in and who doesn't, the people with the most CPU time have like a completely disproportionate amount of power over the network. And by separating these two out, you end up with sort of easier decentralization, although simply the lack of proof of work kind of helps. And then nominators basically vouch for validators, and as a result, they give up some of their stake, but they don't actually do the work of validation. This is similar to like delegated proof of stake, which is a thing that the company that shall not be named is interested in. There's a joke for one man in the audience. I hope you appreciate that. And so yeah, the nominators and validators, they don't lose money if they succeed. Whereas if you do nothing at all, your money will become less valuable just because of interest. So that is an incentive for them to continue doing this. Collators don't get any of the currency of Polkadot itself. They simply get currency of whatever the parachain is. So that's completely siloed off, and that's dependent on whatever the parachain wants them to have. For example, you could implement getting the transaction fees. If people put transactions and you collate them, then you get a proportion of the transaction, for example. But you don't have to. And then fishermen, as I mentioned, they just get some of the bond of the validators or nominators and/or nominators if they find out that they were either evil or stupid, which are the two things we're trying to defend against mostly. And yeah, we end up with sort of consensus without strict ordering, which is one of the things that the current blockchains have. They have a strict ordering where everything depends on the thing before it. Because with this, because the parachains are only communicating over the relay chains, they don't have to have a strict ordering between themselves. Between themselves, unless they're communicating with each other. And so you can do these things completely parallel, and you don't have to wait on the whole network to have consensus to continue on one step. You only need to have consensus over the relay chain, which is only a fraction of the transactions in general. And also, I don't know how much this is going to mean to anyone, but economic finality is super important and super cool. And maybe just talk to me if you give half a rat's ass. So here, what we've done so far, I'm going to say we. I didn't actually. I've only actually done anything with the light client. These other things are not people much smarter than me working on it. Expanded proof of authority. So we have a proof of authority network, which Polkadot will build on a lot of the concepts. So proof of authority, as I mentioned before, you have a set number of authorities, and as long as they agree within themselves, then the network is valid. Proof of stake, as we would implement it in Polkadot, other forms of proof of stake, would essentially be the same thing, except you would have some kind of voting system, which is based on whether or not the fishermen and the nominators think you're cool. It's kind of if Bitcoin, Ethereum, everyone does everything, you could call that direct democracy. Actually, how it works in practice, but it works for the analogy. Whereas Polkadot is more a representative democracy, except with full transparency, so it actually works. Integrating light client support. Oh, okay, let's go. Integrating light client support. So we have clients that don't necessarily have to do any work at all. They just they do the minimum amount of work possible in order to accept that the network is correct. And therefore, you can participate on the network even if you have like some rubbish 60-year-old dumb phone, as long as you have an internet connection. Which iPhone does, but everyone in this room does, so who cares? Bridging Ethereum like chains. So currently we have Ethereum and Koban, the proof of authority chain. We have a bridge made by the guy who was originally going to come here, Marek, which basically means you can send coins between the two in a decentralized manner, without having to rely on central authority. We don't have any bridges between any other networks, but this is because Koban and Polkadot are so similar in the way they achieve consensus. This is sort of a good way to have a proof of concept for the upcoming project. So stuff that we want to do in the future and is in process now. P2P networking. This is my thing. This is my job. We have a thing at the moment called Dev P2P, which is kind of similar to Lib P2P, but bad. And so we're making a new version of Lib P2P in Rust that we can use in our product. That we can just completely replace Dev P2P with. Lib P2P is the basis of IPFS, which you guys probably actually heard of. It's basically IPFS, but without files. Almost all of IPFS is Lib P2P. It's powerhouse. And generalizing over state machines, this actually has been done by Robert Habermeyer. Very, very smart man. And we, internally in Parity now, the state machine of what Ethereum does between blocks is pretty much, you could swap that out for something else if you wanted to. We don't, because we're an Ethereum client, but it would require very little work in order to do so. And so we've sort of proven that it is a useful thing to be able to, and a possible thing to be able to have consensus without state. And so, if you like working for free, here is some good stuff that you can do for us for free. Also, if you like working for money, Polkadot, Parity Tech is hiring Rust developers. We're hiring JavaScript people, preferably full stack, people who can do Node and people who can do front end. Yeah, and if you know Rust very well, we're looking for people to work on the core, so that fun stuff that I was talking about before. I think we need anyone else. I'm looking at this guy. I mean, you're not Parity. He's always looking for. You're swimming in the same pool.
Yeah, I mean, we're looking for
Okay.
designers. Anyway,
Oh, yeah, you put yourself out of business.
What?
So you put yourself out of business. All right.
Always.
If you want to look at our stuff, there's the Web3 Foundation organization, where I'm not sure how much of that is public. We certainly have the white paper public. If you want to, yeah, everything. Absolutely everything. Cool.
Yeah, it's open source.
What are we paying GitHub for? And then Parity, we also have our own organization in which lots of fun stuff is hiding. Of course, there's the main repository of Parity itself, which you should totally look at and give some free work. And then we have GitterChat on the Polkadot white paper if you want to talk Polkadot. We also have Parity Gitter, which I think is also pretty active. I don't go on because I value my sanity. And then we have the Polkadot Network website. If you want to learn about the current state of the project and what's going on. We also have a Twitter account if you like tweets. And then we have a riot channel if you like riots. So, and also if you like these people. Okay, I have no more slides. I feel like we should just have a big thank you. So, thank you. Do you have any questions? Hey, this guy.
Why do you call MyEther1 like a centralized service and put it in the same box as Kraken? I don't understand.
Oh, sorry.
Between Plasma and what?
Sorry?
I wanted that as well.
Oh, okay. Sorry. That's just me not knowing about mine. That's my bad. I just made it a mistake.
Okay. And can you compare like Polkadot to Plasma? Like it sounds similar?
No, I also. So as I said, I've been in blockchain space for 6 months. I know this stuff pretty well. As far as the community stuff goes, and if you want me to compare it to other established stuff, I only know what I'm precisely required to know. If you want to ask more about that stuff, I can know about it.
So Plasma is to do with scalability, whereas Polkadot's to do with interoperability and shared security as well as scalability.
It's also that Plasma is mostly for financial operations and Polkadot is for more.
Plasma is smart contracts, right?
Huh?
Sorry?
Plasma is smart contracts, not bound to.
No, it's not bound to anything, but one of the main finalities is a financial, what do you call it? Huh? Yeah, you know.
What is the difference between Cosmos and Polkadot?
So code.
If Plasma is just smart contracts, then Polkadot does not necessarily have to just be.
I think Cosmos is based on sort of token transactions between chains, whereas Polkadot is more sort of general information between chains. So smart contracts.
More what? I'm sorry.
More general information between chains.
Rather than just being.
So I'm from the creative team. I'm not. So just
they just know these particular technologies.
just so we're all aware.
But yeah, I do know it's more like just an exchange, whereas Polkadot does not necessarily have to be about blockchains, communicating about blockchains. It can be about someone who knows some stuff, a weather service or whatever, was one of the examples.
Is it like a protocol, like an OTC, like let's say like 0x project that changes cryptocurrencies from one chain to another chain, or?
So it's not just that. It's so essentially it's kind of pretty abstract. It's more or less just a way for various technologies to agree on the state of each other without necessarily having to have some authority. So sure,
you'll become a centralized authority, right?
Well, I mean, so Polkadot would, as a service is one service, but it is run entirely by the community, whereas something like an exchange would be run on one or by one corporation, and does not necessarily provide the kind of decentralized guarantees of this one point where everything funnels in and funnels back. Whereas Polkadot, because Bitcoin and Ethereum via Polkadot can agree on each other's state, and they agree that Bob has 50 quid to give, they are okay with then passing that money back out. It's
like an OTC platform, then.
Sorry?
Like an OTC platform.
It's similar, but it's more generic. And honestly, we're getting to the point where my limits might be right now.
So basically, Polkadot is pretty agnostic about what it's sending to and from and delivery. And any pattern you want to plug into it, will have like its own Plater, which Plater is basically a full node of that chain. So if you're running the Ethereum parachain, then your like Plater or has to run a Ethereum full node. And if you want like credits to Polkadot, then like there needs to be like some bridge nodes running between the original running class of the Ethereum node. And if you want to like send a message somewhere to like send it to presumably a smart contract in this case, and then the smart contract can like can send an event, and then the bridge node will like declarator bridge node will produce a block of those events that should go out to the block method, and the validators gather all the blocks from all the parachains, and then they use a block on the relay chain, and other parachains can read those blocks and then pass those messages to different chains. So you can basically transfer not just like finances, because you can like send a token to like this smart contract that's like on the bridge and just like gets frozen on the smart contract, and then you can move it somewhere else and then back and you can recover it on the queue. But you can send basically arbitrary data, and the parachain doesn't have to be a chain. It can be like a government agency, issuing no identity, and they just like produce blocks that aren't necessarily bugs, but they this guy now is like whatever, just hashes this identity or something, and they just put this down, and then Polka doesn't care. It's just like interfaces with them, and you can read the identity on Q or whatever. That's my own lesson. I'm just saying, thanks.
Anyone want to just yell so I can pick up on
How do you prevent collision between fishermen and validators?
So how do you prevent them disagreeing?
I mean, they can agree option to, because fishermen will verify the behaviors of validators.
Yes.
Right? Okay.
So,
the fisherman actually did, so the validator provides these blocks by the calculator, and the calculator provides, as far as I also understand, which I could be wrong, but I think calculator provides like a zero knowledge group that the validator can validate. But the validator, as long as the validator can run like a lot of material, you can actually know what happened to Ethereum. So the fisherman is then, in case some validator is some bad now because it's like wrong calculators, you can like point it out to the validators, and then those validators will manage it wrongly.
So there's no incentive to collude in it, because then there isn't actually a winning scenario.
You mean a collusion between the validators and the fishermen?
Yeah, so that was a question, right? Collusion between validators and the fishermen.
Collusion. Sorry, I thought you said collision. So I was thinking you meant like them basically just said she said. No, yeah, collusion. So of course validators could pay fishermen, but there's a point where like that's not economically advantageous, and you would have to pay all of the fishermen. And so if other people are fishermen and you pay them, then if the one person who's there has a large economic incentive to them,
if you only need a single honest fisherman per part.
Yeah.
So even if like corrupt everyone but this one guy, you're still screwed and you lose your stake.
And anyone can be a fisherman.
Okay, so you need only just one honest.
Exactly. Yeah. I mean, obviously, the more you have, the more likely you are to catch something. But it's only so computationally expensive to be a fisherman, so it's not too bad if there is only one. Thank you very much.
One last question. What do I do by owning dots? Like what?
You keep the network secure.
But I own the
Charity will solve you by staking it, and so as a result, you can then have those dots not decrease in value or increase in value if you would like to phrase it that way. So if you stake these dots and you do work with these dots, then they will you get more dots, kind of. You will not get less, whereas everyone else who does not do this would get less. Dots would decrease in value.
Are you guys creating more dots or?
I think that there's actually no.
It's inflation. You get rewarded, and there's inflation on the dots.
So we have
So when you stake your stake, then like you get rewarded for taking your stake on those validators. And if you don't, then your dots decrease because the value of the dots decrease because of justification.
But how much dots do I have to have in order to be able to do the stake? Because it's only the highest stake that is able to. Right?
I don't think it's the highest stake. I'm sure anyone can be a validator if they like. Sorry?
Who is selected to do the proof of stake?
So I believe that is to do with the nominators, and I think it's more like the more stake you have, the more
control you have.
How is it then different in terms of like, I'm just thinking, you explained, proof of work. I mean, the problem is that if you have the highest, if you have a high CPU, that gives you a lot of power.
Sure.
So if you have a highest stake, also gives the people with the highest stake the highest power. And how far does that solve?
Right, so very, very true. The differences are that it's extremely easy to kick someone who's abusing their power off the network by pointing out they're abusing their power, and then that decreases the trust, and also they just lose some of their money. And number two, the power you get is linearly scaling. It's not exponential like it is with Bitcoin, where like the more CPU you buy, it is cheaper per CPU. Like you get economies of scale, whereas with Bitcoin you don't get the economies of scale. You get if you have twice as much, you get twice the power. But of course, also if you use this power, if you stake twice as much, then you lose twice as much if you abuse it. Whereas with blockchain, with Bitcoin, if you abuse your power, people just ignore you, which is that's not really. I mean, you've wasted some time, I guess.
So like proof of stake also has like this nice property that even if for some reason like you get like some bad agents in the network and they all like allude to compromise the network, the honest thing is to like still fork the network and can decide, okay, these nominators just have no thoughts in. And they just make their own fork and then you continue on that. Which is in proof of work that's like equivalent to like destroying the hardware of the bad miners, which you just physically cannot do. Like if someone makes like a 51% attack with Bitcoin, and okay, you make a fork to like correct whatever happened, they can still make a 51%, unless you now increase your
on the new chain.
Yeah, whereas
just
proof of
chain
stake,
to the new chain.
yeah, where proof of stake you can just destroy the state of bad agents.
Something else?
Okay, well, thanks very much, Jack, for stepping in. And thank you, everybody, for coming to a fairly epic first ever Matrix meetup, and thank you for surviving. Feels like we should take a survivor's photo or something. In fact, should we take a survivor's photo? Anybody object to being immortalized on a CCD? Yeah, quickly. I'm gonna go. There we go. With flash and everything, amazing, perfect. And yeah, thanks everybody. I hope it was fun. And I think we have to clear off. Grab one more here. Yeah, we've got time for enough beer and to kind of relax and share all stories. And then we got to head up. Hello, everybody online. Hi.